So now we're going to move on to Poisson for rate data. And does anybody remember from class, why would you want to think about rate? Why would you want to model the rate? Welcome, Asabe. Welcome, Zubaida. Okay, so sometimes time is a confounder in our data set, and we want to account for it because we've collected this data over time. We've collected this data among resident doctors over time, and we want to know if the time that they spent in the residency program, if it has any effect on the number of hours of calls or the mean number of hours of calls that they took. So we want to put that in our analysis and account for it as a potential confounder. So to do that, we will take the same set of line of codes that we had earlier. So this model, name it whatever you want. We use the GLM command. Our outcome variable is the mean number of calls. Our predictor variable is still the gender. We're still interested in knowing if there's a difference in mean number of calls between men and women. This is the name of our data set. We specify to R that we're doing the Poisson, we're using the Poisson family, and the link is the log. However, we now introduce an offset term, or the potential confounder that we want to look at, we want to account for in this regression model. And instead of, so the variable is called the residency years, the number of years of residency, and we take the log of it. So this is what we do. This is introducing the offset term, the log of the number of years that the people spent in the residency is the difference between what we did earlier and what we're doing now. And this one just accounts for saying, is it possible for the number of the call hours to differ by how long people have been in the residency program? When people are new in the residency program, do they generally take fewer calls, or do they take fewer calls as they progress? So that we'll then say, maybe it's not so much of the gender, maybe it's also the number of years that they've spent in the residency. So does this make sense?
Yes.
Okay. So we're going to run the model now. And this is what we get, right? R will always tell you this is the formula that you call. This is what you asked us to do, and then this is the intercept, and this is the estimate of the independent variable. So, what do you notice here? Let me ask. Does anybody notice that even though we put an offset term in the regression equation, there's no coefficient for it, right?
Yes.
Because it's not treated as a predictor variable. Okay, so like we know, the Poisson regression is a log, it's modeling the log of the mean. So for us to be able to interpret it and convert it, like regular numbers that everybody understands, we take an exponent of, so EXP, the exponent of the coefficient and of the confidence interval. And we just ask R to bind it into columns. So that's what the C bind is. So does anybody want to take a stab at telling us what they see and what this means, or what this may mean? Hello? Asabe, are you with us?
Yes, I am.
Okay, so have you run your codes up until this level?
Not yet.
Okay. Where did you get stuck? Hello, Asabe, where are you in the code journey? Are you able to follow along? Let me ask that question first.
Sorry, because I joined late, I'm still like trying to catch up, but 1 second. Sorry. I thought I was muted initially, but I haven't gotten here. But I'm gonna catch up soon.
Okay, no problem. Is there anyone who's at this point?
Yes, I'm there.
Who said yes, sir?
Abbas.
Abbas. Okay, thank you, Abbas. Any other person at this point? Because I don't want us to just keep rushing off while people are struggling to follow along.
Yes.
Okay, Ozioma, thank you. Mahmuda.
I am following, but not with my laptop.
Okay, yeah, not with your laptop. Okay, great. Okay, so does anybody want to tell us what this out, if you look at my screen, for instance, what do you think this output means? Okay, so in the interest of time, I'll just go on and tell you what I see. So here we can see we've taken the exponent of the coefficient that we've taken the exponent of the coefficient of female gender. The coefficient was negative 0.1474, and the exponent is 0.86. And like Abbas explained earlier, when it is less than 1, you subtract it from 1. So when you subtract the mean from 1, 1 minus 0.86 lands you at 0.14. And when you multiply that by 100, you get 14%. So basically, we're saying that the call duty rate was 14% lower among female residents compared to the male counterparts. Does it make sense? So we're basically saying the rate among the female is 0.86, while the rate among the males is 1. So the rate among the female is lower. Please ask a question.
Please, a question.
Hello? Okay.
Hello. Okay, from the code we used, just like you said, the difference between the first one we used when we're not looking at time as a possible compounder, then this one we introduce offset to the residence log of residency years. So in the interpretation, can we I couldn't see any introduction of the residency years was controlled, even controlling for residency years in the interpretation. I expected the interpretation would be the females have 14 wrong calls on average of 14% lower when you compare it with the males. So while I expected the result should be while controlling for number of years resident or residency.
Okay, so the offset term is not the same thing as another predictor variable. Remember from many weeks ago. Remember from many weeks ago when we had multiple linear regression or multiple logistic regression, we would use, like plus, it would have been female plus maybe another predictor variable, right? To make it
Yes.
multiple. So this is not a multiple regression. This is not multiple regression. So it is not, we are not controlling for the number of years spent in residency. Instead, we're converting it to rate. Here, where is it? If you look at this first one, where we just had female and we did not put the, we did not use it, we did not use the number of years in residency as an offset term. We basically said, we looked at the mean number of calls. So we just counted the calls and we said mean number, male, female. However, the second one, we're basically saying rate, consider the number of years that they spent in residency as they've spent in residency as a denominator. So it is not another predictor variable. It's a confounder that we decided to use to convert our outcome from mean numbers to rates. So if you look at this one, it's now talking about call GT rate, not the mean number of calls.
Thank you.
You're welcome, Abbas. Is everybody clear on this? Can we move on? Okay. So now we're done with the Poisson regression. We've talked about Poisson regression with counts and Poisson regression with rates.